focus on the high mountains. In the valleys, where most of the climatic stations were, there's very, very little rainfall, maybe even desert-like situations, as you can see on these pictures. So we must know what happens on the high mountains, on the very high mountains. So on the next slide, please. Yes, you see the different approaches to understand what happens in these high mountains. You have two frames. The upper frames is global to regional scale. The lower frame is regional to local scale. And in the upper frame, global to regional scales, you see that we mainly work with data from satellite, which have the advantage that they are rather homogeneous over large areas. We use models, general glacier models, atmospheric input by general circulation models, and so on. I think you are somehow familiar with it. The very important point is how reliable are these data? So we must have ground control. And that is what we see on the lower part, ground control. There we have stations in the valleys. They follow the WMO rules, but the lower valley situation is completely different to what happens in the high mountains. There you cannot use what is usually used in the valleys, in the lower parts. You have to have very special sensor systems. I will show one or two just afterwards. We need a lot of field observation. We need proxy data. That means if we would like to understand what's going on, that means for instance, geomorphologic information, which has been then translated into climatic information. We need tree ring analysis, sediment analysis, which provide us long-term series, which are very, very important, finally, to create the vertical scales and to verify the model and remote sensing approaches by satellites, which is shown in the upper case. Now, next slide, please. Next slide. Can I have next? Yes, okay. This image, which has been produced by a team with CAB and so on, shows the whole South Asian mountain systems, and the circles indicate for each square here for a regional scale the standard error, the size of it, and the color indicates the trend of elevation difference per year, elevation of snow boundary going up, going down, glacier or water balance going up, going down for the high mountains. And you see there are the red ones, which clearly show a decrease of the reserves in ice and snow and so on, drying out, climate change very dramatically. And the blue and white ones show the stable areas, and the blue ones even an increasing amount of ice and snow, which finally is known or became known as Karakoram anomaly. Now, if we go and say, okay, that's mainly based on remote sensing and model-based information, which we just discussed before. If we go now to the ground and have a look at it, please, next slide. Next slide. Okay. You see here vertical gradients of annual precipitation totals. That includes, of course, snowfall as well. It's liquid and dry precipitation. On the left side, meters above ground, and yes, on the lower axis, the amount of rainfall or precipitation. And there are for very close region, Hunza Basin, mainly in Hunza Basin, including Batura, 4 different results from further models, remote sensing, but also ground truth. And you see they differ in an enormous way. Number 1 shows rainfall maximum at 6,000 meters with some 1,200 millimeters rainfall. The last one, which we created some years ago, shows that the maximum height altitude is more or less the same. This doesn't really change, but the amount of rainfall is much, much higher there. So with this difference, it's a real problem to feed the models for the runoff in the lowlands. So we must become more clear. But the question is, why do we have so different results from the amounts in the field? This is somehow shown in the next slide, please. Next slide. Yes, it's just one example what might contribute to these differences. We have a lot of drifting snow. You can see it on the left side. It's on the Batura wall. These are not clouds up there. This is simply drifting snow, which has been registered on the backside of the mountains, now comes over the mountain and is registered again. So there are double registrations of the same snowfall. Or on the right side, you see an avalanche, which just brings down, and it's also again in the Batura wall area. Daily, you have dozens of avalanches like this, which move rainfall results, that means snow, from places up there to places down. Again, these are very complex systems. On the next slide, please. Next slide. Takes a long time.
Yeah, it's the network issues, that's why.
Okay. It shows another problem. As I said, in the low valleys, you can follow the WMO rules of how to measure data, climatic data, in a very precise and comparable way. In the high mountains, and that's not very typical here, but it shows what's going on there. You have not the same situation. There is snow cover. You cannot, sometimes 5 meters of snow. So you cannot put your sensor on 2 meter or 1 meter as in the lowlands. You see on the left side the example of a Wapta station on Kunjarab. The rain gauge is at 10 meters altitude. The snow is measured by a snow pillow. That means it measures the weight of the snow cover. On the right side, you see a station which has been installed by our team. Snow depth is not measured with a snow pillow, but with an ultrasonic sensor. And the rainfall, the liquid rainfall, is measured by a tipping bucket on the ground. So there are differences, simple resulting differences in the amounts simply by different methods of approaching. So we need here a clear coordinated approach. And that means on the next slide, Next slide, please. Oh my goodness. Yes, we need for the high mountains, that is very clear, and it has been outlined by Isimon as well, standardized comparable approaches for field measurements. And this means you see here a very simple approach. You have a valley from right to the left, it goes down. This is this dashed line. You have altitudinal elevation curves, and it shows the topography. We have to make clear that for each bigger valley system, we need a so-called baseline station, which defines how to measure with what sensors this approach in the valley. And then we need main stations, one on the top, one on both sides of the valley, that's these blue ones, and of course auxiliary stations at special points. This has to be really achieved, and the different teams have to sit together. Unfortunately, when you go to the field, and maybe until recently, stations have been put where it was possible to reach, on a roadside, somewhere where it's very simple because there's a hut nearby and so on. But it's so different in the mountains that we have to say, no, that's not the way. We must try to have a very clear context. Okay, the next slide. Next slide, please.
Yes.
Yes, I mentioned proxy data before. And proxy data, that means these are not direct climatic measured data, but indirect ones. For instance, very local changes in the irrigation possibilities. You see on the left, in the upper part, you have two mountains, the same mountains in two situations. On the left side, you see glacier, snowfields. Sorry?
That will stop.
No, okay, wait, sir. I'm asking Dr. Irfan to use.
Sorry?
Okay, it was about a
on the left side, you see the glacier is still rather high. It provides water for irrigation. At the end of the glacier, that's very clear. There you have the outlet of the water, but you also have on the terraces on the left and also on the side, from side moraines, channels going to these terraces, enabling irrigation. On the right side, you see the glacier is retreating. What is the result? At the lower part, at the end moraine, you still have enough water. The water is coming out. It's even more water because the glacier is melting, which sometimes creates problem, but it doesn't really affect the local situation. Whereas on the terraces, through the side moraines, water is not available anymore. That means these areas are really dried out. That's a direct consequence of climate change and retreat of the glacier. That's an excellent auxiliary data, which I think we should, proxy data, which should be taken into account as well. On the lower part, you see a very concrete situation. It's on the Gilgit River, Passu, where at Passu, that's on the right side, there's a lot of water. It's sometimes too much water, no problem for irrigation. Whereas Borit, these are the terraces, has more or less completely dried out. And that's very basic proxy data. The next slide, please. It shows another type of proxy data, climate data derived from tree ring analysis for 1,000 years now. And it's summarized system which we published some years ago in Nature, and it includes two systems for our area as well. The very upper one, which is in red here, you see derived precipitation amounts, or no, it's set scores. It's a statistical approach from the year 1000 to the year 2000. And we see very clearly it's going up, it's going down. But in the very last maybe 150 years, we have definitely an increase in precipitation in the high mountain areas of Pakistan, which shows a little bit this Karakoram anomaly. In the lowest graph, you have another one for indicating now temperature systems. And there the red line, which has been produced by one of our PhD people for Western Central Asia, shows also for the 1000 years it goes up, it goes down, and it went up in the last 150 years as well. So these proxy data should be included in our model approaches. Now I see the time is really running out. I come to my next point. Please, next slide. Yes. What I think, and what I said at the very beginning, I think the socio-economic drivers and the changes related to it finally lead to increased marginalization and to increased risks, which have nothing to do with climate change. And I would like to show just a few slides illustrating this. Please, next slide. Next, yes. In a very simple way, we have, you can go wherever you want, especially close on areas which are open by roads and so on. We have a dramatic change in the mountain agricultural, social, cultural organization. On the left lower part, you see what's happening. Of course, globalization is going everywhere now. We have formal education, we have communication systems, the demography I have mentioned before, things which lead to the fact that many of the young people from before rural areas simply leave their places. That means it will change the agricultural systems in the high mountains and in many other areas as well. And on the lower side, on the right, you see it leads to migration. Urbanization, we have also discussed, this is an absolute clear process in the big areas, Karachi, Rawalpindi, Lahore, and so on, but also in the mountain areas. You have urbanization on a lower scale in the mountain areas. And this, all in all, creates fundamental changes to rural areas. On the next slide, next slide, please. You see, it's very visible. Karimabad in Humza, this well-known, really historic place, now tourist attraction. Everywhere you see network, communication network, antennas, and you can go through all these areas, you see it everywhere. That means communication becomes very fundamental. Next slide, please. Urbanization, it's a very, maybe a little bit a dramatic picture from Islamabad. It's a very globally oriented type of urbanization. And again, here you see with the song 4G, your communication is obviously the thing. And it happens everywhere. It happens in Europe, it happens wherever you go, in Asia and so on. We see it with tourists. students, and so on. Communication is basic. Now, if we go back to the mountains, and that's the next slide, please. Next slide. Next, yes. Gilgit, very high up in the mountains. It's one of the centers now also for the Karakoram Highway, for the economic Pakistan-China economic corridor. It's a place which is rapidly growing. And you see here just one section of this town of Gilgit. It's called Judyal. It's a huge debris fan which has been fed from this valley. You see it on the top, melting glaciers, landslides, and so on. And this whole fan is debris fan created. And you see it's a picture from 2004. I have unfortunately not the ones available earlier where you don't see any houses or just some few. 2004. And on the next slide, please, next slide. It's 2021, the same area, almost completely covered with houses on this debris fan. And it happens from time to time that there are still floods after rainfalls, after rockfalls, and so on from these side valleys. And on the next slide, please, next slide. You see just a very simple example. It's at the very top of this debris fan. You see from the left side, it comes in the water. And there was in 2004, that's the upper one, there was not a very big flood, but it was a flood which destroyed quite a lot of, fields, houses, and so on. It didn't go too far down, but on the lower part, 10 years later, you see that again, the whole area is built up. Very risky places, but people don't have a choice. They have to go somewhere and to build it. That's what I mean, marginalization. And on the next slide, you see further down, when you go down to the Indus River, near Dassu, where at the moment a big power plant and a dam is built, you see side valleys with houses which show exactly the same problem as I just mentioned before. It's a small village. They have created school buildings, 2 school buildings. There's a local administration house. And then again, there was a landslide in the valley. Maybe climate change, maybe not, who knows. Water came down after a heavy rainfall. These new buildings have more or less been destroyed. Some were in the center, don't exist anymore. So that means marginalization creates very, very big and fundamental problems. Now let's go to the last point. Next slide, please. Challenges and chances for the Upper Indus Basin Network and Himalayan University Consortium. Very good. ICIMOD, which is located in Kathmandu and which all the mountain countries are members of it and try to coordinate, approaches to define the problems, to define political outcomes and so on. They proposed, it's some time ago now, we should learn in order to compare the different areas in so-called transboundary transect programs. Indus, Kailash, Kosi, Brahmaputra, Salween, where we focus and coordinate scientific approaches in order to understand what we just have discussed before. And on the next slide, please, you see a map which is absolutely not complete. It simply shows some of the so-called Himalayan University Consortium. There are a number of, meanwhile, I would say 100, I don't know exactly the numbers, some 100 universities joining this consortium, where one discusses what are the problems, how do we educate people, and so on. How do we focus research? How do we have international cooperation, and so on? I have outlined here Abbottabad. By the way, KIU is mentioned as well, Peshawar as well, and many others, but there are many, many more. I have outlined Abbottabad because in 2013, there was a very fundamental conference by ICIMOD in Abbottabad focusing on Himalayan University Consortium. And from there onward, Pakistan started to play a rather important role, and Bahadar Nawab from Abbottabad is now one of the leading persons in the Himalayan University Consortium system. That's why I outlined it here. Now to the next slide, please. And we soon come to an end. There are challenges and chances for this Himalayan University Consortium, where hopefully all of the mountain universities take part as well. Topics, it's quite clear, regional aspects, that's their chance. They are in the region. They can, with their students, with their scientific teams, work in their surrounding. Global relevance, mountain issues, and high lowland perspectives. They can introduce and propagate methodologies on international standards. They can create regional clusters which also have international links. Then this, what I just mentioned before, these ICIMOD transects, transboundary approaches. For instance, the left one, the one I mentioned, Indus, it includes China, Afghanistan, Pakistan, part of India. So it's a somehow overlinking approach. Coordinated curricula. One should discuss with each other what are the important curricula also for practical work, field stations, and so on. But that's what outlined in red there. It needs the readiness and the dedication to promote these concepts. And there I think one could do much more up to now. I have been part of ICIMOD and could visit all these or many of these universities, and it's just closed and not really open. And that's a real point. So on the next slide, please. We have to make coordinated steps forward. We have to make preparative workshops on different issues together, joint field visits so that we learn from each other. We have to install these baseline stations. We have to create annual programs with field campaigns together, courses, workshops, and so on. And then that's what under D, there are many internationally many programs which are similar where we can learn from. Everest K2, ICIMOD, World Glacier Data Center, Alpine Experiences, and so on. There are many more. We have simply to define, and there the Himalayan University Consortium can really add. That's under E, on the last point. We have to define some responsibilities. Who does what? What should be ICIMOD's role? And to the second last slide, please. Next, yes. What I just said before, that has been accepted by ICIMOD, it has been promoted, it has been accepted by regional structures of the Upper Indus Basin Working Group. We have different teams. I just have mentioned 4. These can be 2, it can be 10, or it doesn't matter. They, of course, have their individual components. They have their local or individual research preferences and capacities, but some overlapping issues should be envisaged. Definition of ground-based infrastructure, campaigns, data management, and so on. This has been done, and it should be this goal number 1, comparable and joint approaches and individual components and so on. There we could really go into detail, and it should be discussed as again. Now I come to my last slide. Please, next. Next slide, please. Yeah, it's the last one. It shows once more this dramatic situation. It's from the Indus Valley, close to Gilas, west of Gilas, where you see the desert in the valley situation, and behind it's Nanga Parbat, 8,000 meters and a little bit more, snow, ice covered. And this is the challenge, to understand what's going on. Actually, over the times, now with the discussion of climate change and so on. And for this, I would like to thank you that you were so patient. It took some technical problems, but many thanks for your attention.
Thank you very much, Professor Mathias. It was really a nice presentation. We know that there always comes technical issues while you're dealing with teams, so I think we all are very much aware of that, but it went really well, despite all these inconsistencies in the internet on our side. So Bob probably has a question. Bob?
Yes, thank you guys very much. Wonderful to sort of get this overview presentation, Mathias. I wanted to follow up on your point about the climate record and the use of proxies. You brought that up a couple of times, particularly as you looked at the scientific approaches and understanding the Indus Basin on a larger scale. You mentioned, for example, tree rings, and my question really is, how solid are the proxies that we have access to, and are there opportunities for students to become involved in, for example, investigating something like sedimentary deposits, maybe in some of the glacial lakes, or are there opportunities to find isotopic records in something like cave deposits? I'm curious to learn more about what opportunities there are to increase our understanding of the recent past climate so that we can put the present into better perspective. Thank you.
It's a very difficult question, but you're absolutely right. These are the problems. I would say if we would like to understand what's going on actually in a climatic system, we have to accept that climate is a very dynamic aspect of the environmental system. It's dynamic. Dynamic means intensity has changed, frequency has changed, it goes up, it goes down, and so on. And we simply have not enough precise measurements. Maybe we have them in Europe, maybe for 200 years. In Asia, it's much less. In the high mountains, it's only a few years in many cases. And as I said, most of the stations in the high mountains, Gilgit, Chitral, Skardu. These are stations in the very dry lower parts of the valleys. No stations high up. So we need extending the station network. That's one thing. And the second thing is climate. That's very clear. Beside, tectonic aspects and so on, has an impact on the environment, on vegetation, on sediments, on trees, and so on. And there we have to try to understand the information which is in it. We cannot just take tree rings and say, that's it. We must combine it. And there, your question, how can we come to this? That's a real challenge. I simply can tell you there are many, many international and meanwhile also national research programs which include all these aspects, isotopic, sediments, tree rings, information, and so on. But it's not combined, and universities, which I think should really take part in it, are in most cases excluded. So use the possibilities and the international approaches I have mentioned. Everest K2, that's an Italian program, which is working in the area for maybe almost 100 years. It started with Desio 100 years ago, and they are there again and again and again. Sometimes they are thrown out, sometimes they come in again, and so on. But it's a chance. It's a real chance for the regional universities to join these teams. And the same with our team, but also there are Dutch colleagues, Americans, many groups, and so on. So it's a question of organization, of opening, of and there the Himalayan University Consortium, which is now a very strong central organization, can take a part of it. But you're right, it's not simple. That's a real challenging scientific situation. I don't know whether I gave an answer, but I understand your question.
Thank you.
Dr. Swanger, please unmute your mic.
Do we have any other comments or questions? Bob, do you want to continue or?
Yes, I'd like to follow up. I think that there's a danger that some of this sounds very complicated, and your illustration of the installations of the weather stations, it seems very complex, and a 10-meter tower is very amazing. I'm thinking that there are also some low-tech technologies like repeat photography, for example, that could be done by students with relatively little technology. For example, if you had established, some stations where every year a photograph was taken. Just for example, the image you've got on the screen right now, looking near Chilas, if that picture was taken every year at the same time of year, or even once a month every year, you would see possibly changes that could be at least qualitatively evaluated. And then the other thing I really want to point out is that sometimes the proxies are in special places, and for example, the coring of ice done by Lonnie Thompson. He's done many mountain glacier coring exercises where he gets the patterns from the snowfall in special places where the ice is stable. And there may be, somewhere around Skardu or somewhere, there might be some small lakes or ponds where, again, relatively low tech, you could gather, for example, piston cores or something. I'm just trying to see if there might be some progress made by the university consortium using students using relatively modest technology to quantify some of these issues across the Himalayan range?
Yeah,
Thank you.
thank you for this comment. You are absolutely right. There are also simple approaches. Repeat photography. We made it on Batura Glacier from a high elevated place down to the glacier and to the opposite mountains. And we took pictures several times a day. And well, they were stored on a disk. And twice a year we could go up there and took it. And then you really see, and that there you are right, you see the movement of the glacier. That's very interesting. You simply can look, oh, it's moving. You see the snow boundary going up, going down. You see the differences. There are extremely different expositions and behavings. You see the avalanche systems coming down. You're completely right. One can do it. Of course, it's very simple. The picture you just have in front of you, that's from Karakoram Highway. There, to take every year several pictures is not the problem, but it is also not so instructive. One really should go into the side valleys, into expositions where you can see what is happening. The second point about proxies at special places. You're right. That's what I also think mentioned before. One cannot just take one place and that's it. For instance, one very important place, which usually has been observed several times now, is Snow Lake between Hishbar Glacier and the glaciers going eastward to Gilgit-Baltistan. It's on almost 5,000 meters altitude, huge plateau with snow cover, and it has been digged many meters down, and you could see the layers. That's a very it's not easy to go there, but it's a very exceptional place. It's more difficult when you go to slopes, to valleys, to debris-covered glaciers, as you just mentioned before. But we have to try and to compare and not to rely on one single place. One has to compare it. And again, the first climate stations, which have been set up by a number of teams, including government teams, they were not put at, how can I say, at really relevant exemplary places, but just where it could be placed. And that's a problem, I agree. But once more, the Himalayan universities, they are up there. They are in the mountains. They can, from their places, I think of Karakoram International University or Peshawar, within 1 or 2 days, you are in the area. So hopefully this will be changed in the future, or it is on the way to be changed.
Thank you, Professor Mathias. Professor Kasimjan probably has something to say.
Thank you. First of all, I would like to pay my sincere compliments to Professor Mathias Winiger for his wonderful presentation. I'd like to talk a little bit about the dating of the trees, rather not talk, but ask question. That is, you dated the trees and you said that there were, hopefully, I think this is what I understood, that there were fluctuations, rainfall or precipitation fluctuations. Probably this has been determined from the thickness of the rings, whether there was plenty of water available or not during a particular year, or did you use any isotopic systematics also on these 3 rings? And the second question is, do you see a pattern of, let's say, a prolonged dry period in the area and then followed by a prolonged wet period, a relatively wet period, or was it haphazard? Thank you.
Okay. The first one, tree rings. That's quite a complicated thing, you know. You mentioned it. First of all, which trees do you take? Just very young ones, very old ones, at the tree boundary, somewhere in the middle of the forest? Where do you take? At irrigated places or dry places? So that's one thing, to choose the place. The second thing is, at the very beginning of the tree ring analysis, the tree ring width, you know, how large they are, that was an indication, oh, the tree was growing rapidly or slowly, had a good situation or a bad situation. Meanwhile, that's much more sophisticated. You can derive with isotope analysis out of the tree rings humidity or drought and temperature aspects. That's has been developed by different research teams. I know it from Switzerland, I know it from the United States, which meanwhile are available. One can rely on it. And they really provide good information for the local position where this tree grows. If you would like to know about a regional one, you have to, of course, to analyze maybe 100 or 1,000 trees, which have been, this has been made by some of the teams, including our team, covering not only North Pakistan, but also part of China and so on. And then you get somehow a picture which really gives you information on an annual basis, sometimes even on a seasonal basis. That is one thing. The second point about wet and dry periods, well, it is in that's actually, you should give an answer there because it's a really difficult question. If you analyze these information from tree rings and so on, by the way, also, that I even didn't mention in detail, the runoff of the glacier systems is one of the very basic and not easy approaches, really, to get the runoff out of the glaciers. Wet period, dry periods, we can define or derive this wet situation in the high mountains linked to the growing westerly rainfall inputs in the high areas in the North Mountains, which finally lead to this Karakoram anomaly. So we have to link our local information and findings together with atmospheric circulation patterns, which have been derived in models, but also by meteorologists on a global scale. And then I think one really can see how monsoonal systems are moving northward or southward, seasonal changes, which has of course, the result on the rainfall system in the high mountains. But in addition, and that's another point, I didn't mention it, it has been mentioned before by others, you know, dust in the atmosphere. These dust layers in the glaciers, which you can find, or in the snow, black carbon, it's called black carbon. But you have to go to the glaciers and you have to dig to the snowfields, you have to dig, and you can date these layers. And there we see that, especially in the central and eastern part of the Himalayan University range, these black carbons have increased dramatically, and they lead to increased melting of the snowfields and glaciers. So this is locally human-made, and it happens in other areas. It happened in the Alps, it happened in the United States, and so on. It's something which has to be studied. So it's another type of proxy data, and to combine it, that's a real challenge. And again, universities, if they can assist to this, that would be very helpful. I think it's not a really good answer to your question, but I hope we can think more about it.
Thank you.
Thank you, Professor Mathias.
Yes.
I think, yeah, it's Bob again.
Well, yeah, I don't want to take too much of people's time, but I will emphasize the fact that we have a very poor understanding of the Pleistocene, and we struggle to understand the modern conditions, and yet we do believe that the Earth has gone through a series of 20 plus 30 cycles of ice ages, and in Colorado, where I live, the mountains have been sculpted by the ice, and we definitely can see evidence of past glaciers that are long gone. They're not there anymore, but the mountains of Colorado have a very distinctive geomorphology. The shape of the mountains has been carved by ice that has long vanished. And so there's a very strong overprint on our topography from the presence of past glaciers. And my question to the community really is to think about, what did the Pleistocene look like in the Himalayan chain? And was there, or are there, evidences of the Pleistocene cycles preserved either in the geomorphology or in the outwash? And I've often looked at the Indus cone or the Ganges cone to try to see evidence in the marine record. And I think Peter Clift, some of you've heard some of his talks, it's a very obscure relationship. We don't see, at least I don't think there's clear pulses. But a question, again, for the community would be, can the worldwide climate cycles of the last 2.5 million years be found in the records in the Himalayas? I ask that question very broadly. Thank you.
Well, maybe I try to give an answer. Of course, you can find it. And there are many really fundamental and very broad studies for selected areas which show exactly different ice age activities. And you see it in the geomorphology. There are very, very high, long valley, for instance, in the Indus Valley, 2,000 meters above the valley ground, you can see moraines from previous big Indus glaciers, which you can go to Chilas or so. There you find it. To date it in a very exact way, that's another problem. It can be dated, but in a very rough sense. But that's very clear. It was there as well, and it's very nicely documented. My experience, and there I once more say, it's a pity that many of the young teams at the high mountain university say, well, it's nice to be up here, but it would be nicer to go to university in Islamabad or in Karachi or I don't know where, Lahore and so on. There, you have more fun and so on. I always say, if you are interested in, landscape and all what's around it, please go to your mountain universities. There you have it in front of you. There you can go. I tried to organize quite a number of excursions. It was with local universities. It was not always easy to convince these team leaders or the young students to come. When they did come, they said, okay, that was really very interesting. We will do it again. But we have to move. We have to start. And Kasim Jan, of course, knows it very best, and he is one of the exceptions in this context.
I think that's all for today, Professor Mathias. We don't have any other comments or questions from colleagues.
Yes, so before we end the talk,
So
I
yeah,
will
please,
request.
if you want to advertise for or for group photo, ask for the group photo or
Yes.
advertise for a next talk. That'll be great. Thank you, Professor Mathias, for a nice and wonderful presentation.
Thank you to be so patient with this. It was technically a little bit a problem for this.
That's okay. That's okay.
Okay, thank you very much, sir, for such a nice talk. So I will request all of your participants to turn on their camera for group photo. So, okay, we are done. Thank you.
Thank you very much, and
Thank
see
you.
you on
Bye.